Problem number 4 on section 4, chapter 6. For this problem, you have a normal distribution with a mean of 200 centimeters and a standard deviation of 8.6. So this is going to be the individual normal distribution. It says find the probability that an individual's distance is greater than 212.50. For this problem, we have again the distribution with this mean of 200. If you add 8.6, well, the first mark here represents one standard deviation, which is 208.6. If you add again 8.6, you will have 217.2. And they want the probability of a score greater than 212.5. So that score is going to be somewhere here, maybe here, 212. Let's see, 212.5, and that will be from here to the right, this area on the right. This word saying is greater than means they want the area here on the right side of this score, greater than 12.12. So if you want to type that on the calculator, what you have to do here is press second bars. Number 2, that will be normal CDF. The lower score will be 212, that is the lower limit, to 12.5 or to 12.50. Okay? The upper limit, well, you can choose anything like maybe positive 1000 if you want something very, very extreme, very large. 10,000 with a mean of 200 and standard deviation of 8.6, and press enter, and that's how you get this probability. The second part of this problem, part B, it says find the probability that the mean for 25 randomly selected distances is greater than 198.7. So this is going to represent the probability, the distribution of the sample means. Sample means of size 25. Okay. The mean of the sample means, according to the central limit theorem, says that this mean will be the same as the mean of the population, as this individual population, but the standard deviation or the standard error, it will be the standard deviation of the population, this one right here, divided by the square root of n. So the mean here will be 200, but the standard deviation or the standard error for this distribution will be 8.6 divided by the square root of 25. Okay. Let's see, we have 200. At this point, 198 should be, well, a little bit less than that. Let me check what this quantity is. 8.6 divided by the square root of 25 is 5. So um, that's 1.72. So let's see, 200 minus 1.72, that is 198.28. So this mark right here is 198.28. That will be minus, again, the standard deviation, which is 1.72. That will be 196. 196.56. So that score, 198.70, will be something like, I don't know where, somewhere here. Okay, that score, that's the one indicated in the problem, 198.70. And from this mark, they want the probability or the area, which in this case is the same, of getting that score or anything greater than that. Okay, so for this, to find that probability, let's write it like that. So what's the probability that this x is greater or equal to 198.7 with these parameters? We write it like that. We press second bars. Number 2, the lower limit will be 198.70. 198.70. You might keep this upper value as 10,000. Possibly 10,000 is way over here, very, very far away. The mean is the same. The standard deviation, well, that was let me type it here, 8.6 divided by the square root of 25, which is 5 right here. I think there is a mistake right here. The square root of 25, and we press enter to type on the home screen of the calculator, and this is the value we obtained, 0.7751. Okay, so that's how you do part